Hello grade 9 students. Today we will be discussing the electronic configuration. At the end of this session we will be able to write down the electronic configuration of atoms. First we start by recapping what we've learned in the last session. So an atom consists of a central nucleus that contains positively charged protons and non-charged neutrons. The atom also consists of negatively charged electrons that are orbiting the nucleus in the electron clouds or shells. We've also discussed different electrons' energy levels, also known as shells or orbits, where we have K as our first shell, L as our second shell, M as our third, and N as our fourth. Now, what is an electron configuration? An electronic configuration is the distribution of electrons in the atomic orbitals K, L, M, and N. First we start by K. Its number of shell is 1. Maximum number of electrons is according to the formula 2n power 2, where n for K is 1. So 1 power 2 is 1 times 2 is 2. Our next shell is L. L has a number of shell of 2. Maximum number of electrons is the same formula, so 2 power 2 is 4 times 2 is 8. Our third shell is M. Its number of shell is 3, and according to the formula 3 power 2 is 9 times 2 is 18. Our last shell is N. Its number is 4, and according to the formula 4 power 2 is 16 times 2 is 32. Lastly, we have shell electrons according to octet rule. For K is 2 electrons, and for L, M, and N shells is 8 electrons. An octet rule refers to the tendency of atoms to prefer to have 8 electrons in the shells L, M, and N. And we also use the octet rule to fill out the the electron configuration. Question: what is the number of electrons that can fill the M shell according to octet rule? Pause the video and think of an answer. If your answer was 8, then you are correct. According to octet rule, shells L, M, and N can carry 8 electrons. Writing the electronic configuration. Electrons are placed at the lowest shell K, then L, M, and N. Let's take carbon as an example. You see here the normal representation of a carbon nuclide, where we have on the left side our mass number A on the top and the atomic number Z on the bottom. This representation here also is a representation of carbon. We mainly see this one in the periodic table, where we have the atomic number on the top and the mass number on the bottom. Keep in mind that the atomic number is always smaller than the mass number. Spontaneously, we can deduce that the number Z is the smaller number from just the representation of the element. Okay, so in a neutral atom we have the atomic number Z is equal to the number of proton and equal to the number of neutron, and this is already covered. We can use this information to write the electronic configuration, where we have the atomic number Z for carbon example is equal to 6, and we use this number to actually write down the electron configuration. So first we fill the K shell. The K has a capacity of 2 electrons. So we fill it with 2 electrons first. We have remaining 4 electrons from the carbon atom. Then we have our shell L. L has a capacity to fill up to 8 electrons. So we can easily fill 4 electrons. So that the electron configuration of carbon is K2L4, and their summation is 2 plus 4 equals 6. Our second example is calcium. First we locate the atomic number Z for calcium, which is equal to 20. Then we fill the electron shells using the atomic number. First we start by filling K, which has the capacity to fill up to 2 electrons. So we fill the shell K with 2 electrons. Then we fill the shell L. It has the capacity to fill 8 electrons, so we fill it with 8 electrons. 2 plus 8 is 10 electrons. We still have to fill 10 more electrons. Then we fill the shell M. M has a capacity to fill up to 8 electrons. So we fill 8 electrons. Then we have 2 plus 8. Plus 8 is 18. So we have 2 remaining more electrons to fill, which we fill in the shell N. So we have K2, L8, M8, N2. And the addition of all the electrons would be equal to 20, which is our atomic number of calcium. Question: what is the electron configuration of sodium having a mass number of 23 and an atomic number of 11? Pause the video and try to solve it yourself. The sum of electrons in the electron configuration should equal the atomic number Z. Summary: we define the electron configuration as the distribution of electrons in the atomic orbitals K, L, M, and N. We've learned that we use the atomic number Z since it is equal to the number of electrons in an atom to write the electron configuration, where the electrons are placed in the first shell K, which has a capacity of 2 electrons, then fill higher level shells of the L, M, and N according to octet rule, which have capacities of 8 electrons each. This is the assignment. Please solve and distribute privately via WhatsApp. And you're done. Thank you for watching.